Okay, so session has started recording, and now I'm going to share my screen. Okay, so we are in our week 4. Almost we are done with our course. From this week we are starting our inferential statistics, which will cover these 4 chapters: chapter 8, 9, 10, and 12.3. So everyone can see my screen?
Yeah.
Okay, so this week we will have 2 graded assignments on chapter 8 and 9 to be submitted on Blackboard, and then we have homework on chapter 8 and 9, and then we will have quiz on chapter 8, and these to be submitted on my stat lab. So you see, notice here in this week, it's just the assignment on chapter 9, but this will be included for the exam in our final week next week. So you need to keep reviewing chapter 9 once this week is done. So you will be assessed on that next week, okay? So here I will point out certain important things because I have seen that students just read the PowerPoint slides and they just do not look into the summaries which I have posted on Blackboard. So here you see this is the chapter 8 handout, which is the PowerPoint slide. And that's what I'm going to be open and will point out few things from there. And then once you have read the material through this PowerPoint slide, then you can hit on chapter 8 PH Stats summary document file. So this file gives you all the step-by-step you need to follow for PH Stat to do the problems. From now or even from Unit 3, we just saw that we are not using any individual Excel functions. We are using phstat for our solution. So that's what we will be doing here as well. Now here in this, you will see chapter 9 handout, which is a PowerPoint slide. So handouts are in detail for you to understand the concept, and it does include the steps as well of the phstat with the examples included. But then I have added the summary document files as well for each section of chapter 9 which we are covering. So you'll see here 9.3 chapter summary and 9.4 chapter summary. And then I included some practice problems with solutions using phstat so that when you do your chapter 9 assignment, you can read through this one, practice that one, and that will give you a better understanding of how you will be answering the problems. Okay, so everyone is good with that now? And I'm going to be opening all these documents and I'm going to show you from there, and I will do the examples. So I will mostly do examples in this session because it will be very difficult for me to cover the material as well as the examples. Is that okay with everyone?
Yes.
Yes.
Okay. Okay, so let's start with our chapter 8. Chapter 8 PowerPoint slide. So I'm going to point out few important concepts for you to understand what exactly confidence interval means, what are the terms we are using, and what those terms mean so that you have a better understanding, and then you can read the PowerPoint slide in detail to have more in-depth knowledge of the concept. Okay. So as I mentioned earlier that this week we are starting our inferential statistics. So inferential statistics covers 2 parts. One is estimating population parameters, and the second is doing the hypothesis testing. So we are doing chapter 8 as estimation of population parameters from sample statistic. If you remember, first chapter we did introduce the term parameter and we introduced the term statistic. parameter is the characteristic of the population and statistic is the characteristic of the sample. Now, since it is not possible for us to understand, to study the whole population as such, that's why we draw a sample and we estimate our population parameters from our sample characteristic, which is sample statistic. So that's what our chapter 8 is. So we are not doing 8.2 section of chapter 8 simply because, let me just show you here, the confidence intervals, like the population parameters which we will be estimating from sample statistics are population mean and population proportion. Population mean is further divided in two options that we are given sigma, which is our population standard deviation known, and population standard deviation sigma, which is unknown. Practically, sigma is never known. So it is always sigma unknown. And that's why section 8.2, where sigma is known, we are not doing that section. Got it? Okay.
Yes.
So for population mean, we are covering when population standard deviation sigma is unknown, and we will be doing population proportion, and that will be our section 8.4, and then we will do the sample size. Okay, so now that's what the chapter 8 is all about. So let's introduce two terms. One is point estimate. So as we are estimating our population parameters, so if we are estimating population mean, the symbol we are using for population mean as mu, we will estimate that from our sample mean, which will be our x bar. So we say that sample mean is a point estimate of the unknown population mean. So it is an estimate. Why it is called point estimate? Because it is just one single number. That's why it is called point estimate. If we are estimating population proportion, we will be estimating that from our sample proportion. So that sample proportion will be our point estimate. Again, it is called point because it is just one value. Now, point estimates are easy to calculate, but they are not like, provide enough information about their accuracy, because if there are 100 samples which has been chosen, so we will have 100 sample means, we will have 100 point estimates, we will have 100 point sample proportions, so we will have 100 point estimates for the proportion. Which one we should choose? So statisticians come to address that issue by providing the range or the interval estimate. So we find the interval estimate, and that will provide us enough information for the variability, that no matter what sample you choose, we will say that with some given confidence level that the population parameter will be within that interval estimate. So when we find the interval estimate, let me just first introduce that. So when we find the interval estimate, we say that the interval estimate we are finding with the given confidence level. So if I say I'm choosing the confidence level of 90%, then the interval estimate, which is corresponding to 90% confidence level, will be called my confidence interval. And that's where this term confidence has come in front of the interval, because it is dependent on the confidence level. So what we mean by confidence level is that we will say we are 90% confident that the population parameter, whether it is mean or proportion, will be within that particular interval. So if I choose, say, 10 samples, so 90% of 10 will be 9 samples. So I will say that 9 samples will have population mean. It will be only one sample, which is the 10% of 10, will not have the population mean. Do you understand that thing? That's what confidence level means. Clear? Does it make sense to everyone? Confidence level?
Yes.
So when I say 90% confidence level, that means 10%, the complement of the confidence level, is the probability of not being true. That 10%, we call it as level of significance.
Are you going to do an example on confidence intervals
Yes.
and interpreting them? Okay.
Yes, that's what I'm going to be doing. I will be covering the examples more than the actual concepts here, but I just wanted to show you or tell you what confidence interval means, what confidence level means, and what terms which are introduced in finding the confidence interval. And then I will take an example. Okay, so, and I will point out here, okay, so first we will do population mean estimation from the sample mean and sigma unknown. So when sigma is unknown, we introduce a new distribution which is called student t distribution. The characteristics of the student t distribution is similar to normal distribution. That is, it is well-shaped, it is symmetrical around mean, and its shape depends on degrees of freedom, which is 1 less than the sample size. Area under the curve is 1, and it is wider than the normal distribution, which you can see here. So the green one is normal distribution, red and black are the t distributions, and you see that the degrees of freedom for the red one is 5, that means the sample size is 6. For black one it is 13, that is sample size is 14. So as we keep increasing the sample size, it gets closer and closer to our normal distribution. So that's why sample size is very, very important. Okay. Okay, so let's understand one more thing before I take an example, okay? Okay, so the confidence interval is the interval which is generated around the point estimate. So if it is mean, the point estimate is my sample mean. This is x bar. So we are moving either direction of the sample mean, which is my point estimate, so that I will say with given confidence level that no matter what sample you choose, the population mean will be within this interval. That means that the distance I'm moving on either side of my point estimate is my margin of error. This margin of error is depending upon my confidence level. So if I have 90% of confidence level, and if I have 95% of confidence level, what do you think the margin of error will be more for 90% or 95%? So 95% means it is covering more samples, isn't it? That means margin of error is bigger. For 90%, the margin of error will be smaller. If I take 99%, so the margin of error will be even larger than 95% of confidence level. So the width of the confidence interval is, here I have the lower confidence limit, which will be my point estimate minus margin of error. My upper confidence limit will be my point estimate plus margin of error. So if I say I'm plus minus 2% of margin of error, that means 0.02 here, 0.02 here. So margin of error is the interval half width. That's what margin of error means, and it depends upon the confidence level. Everyone got that margin of error, what we mean by this? Everyone understood?
Yes.
Okay. So here, as the sample size increases, margin of error decreases, and the standard error, if you remember from chapter 7, sigma x bar sampling distribution of sample, which is sigma over square root of n, decreases because n is increasing. Okay, so this is the significance level which I mentioned earlier, alpha. So if 90% is the confidence level, alpha will be 10%, which is the complement of confidence level. So it will be 0.01. So the confidence interval gets wider if the confidence level increases because it is covering more of the samples to contain the population parameter. Okay, so now if we were not having our pH stat, we have to do the formula and we have to find this T alpha by 2, which is my critical value corresponding to my confidence level. And then I will be finding this by the formula and then doing all this math to get the confidence interval. Okay, so we will be using our pH stat. So I will take this example and you can see that on PowerPoint slide, this example is being solved using Excel as well as pH stat. So this is slide number 19, which is done through Excel, like t dot inverse dot 2t for the critical value, which you do not need. So I have just, and this confidence dot t for the margin of error, which you do not need because we will use pH stat. So I have pointed out on slide number 23 that you can avoid all the calculations on slides 19 through 22. For example, on slide 19, and this is how you will be doing the using your pH stat, and one window itself gives you all the values. So this is all the calculations. So all these calculations, how we get, I'm going to show you right now. So let's go back to our example here and let's open our Excel. Okay. Okay, so as I said, we are doing confidence interval when sigma is unknown. So you open your pH stat, you go to confidence intervals. The first one is estimate for the mean sigma known, but we are not doing that. So do not do that mistake. We are using sigma unknown. Everyone got that?
Yes.
Clear?
Yes.
Okay,
Yeah.
so we click on that and then this opens up. It needs confidence level. So 95% is my confidence interval. So we are providing 95. Now there are two options. One is sample statistics known and one is sample statistics unknown. What does sample statistics known means? That you are given the sample size, given the sample mean, given the sample standard deviation. That's what sample statistics known means. What does sample statistics unknown means? Unknown means that you are given the data and you are not explicitly given the sample mean and sample standard deviation. So you do not have to calculate yourself first sample mean or sample standard deviation to find the confidence interval. You can just select this one, okay? And you can do the cell range, and I will do one of the examples using that as well. So here I'm given the sample statistics. So sample size is 15, so I provide 15. Sample mean is 5.11. Sample standard deviation is 0.85. And I'm not doing finite population correction because I'm not given the population size. So we are not checking this one, and I just click OK. So now here, if I was using the Excel, I need to first find the standard error using this formula, which we used in our chapter 7. But you see here, the standard error is being obtained here in the same window, 0.2195. Do you see that?
Yes.
So whatever calculations pH stat needs for finding confidence interval, it gives you all those calculations. So this is the one which you provide in green. These are intermediate calculations, which is in white because that's what it needs. Because you see here in the formula, we needed standard error. That's what it is calculating. We need degrees of freedom. That's what it is calculating. We need critical value. This is T alpha by 2. That's what we need. And then interval half weight is our margin of error. It doesn't say margin of error. It doesn't use that term, but margin of error is interval half fit. That's what I showed you earlier, right? So it needs all these intermediate calculations to give you the confidence interval, which is 4.64 to 5.58. Do you understand? Everyone
Yeah.
understood?
Yes.
Yeah.
So, sorry for the pause. Okay. So we need all these intermediate calculations to find our confidence interval. So we can skip all these calculations by hand, and we can skip using this formula. See, if we had to do it by hand, we will do all this math, which we have already got it from here in PHStat. So we'll skip all this. So interpretation here is that since I chose 95% of confidence level, I'm saying I'm 95% confident that the population mean is between this. So if I have to validate certain thing, I will be given the confidence level. Given the confidence level, I'll find the confidence interval and we'll see that if that value is within the confidence interval, it does validate. If it is not, then it doesn't validate. Understood? Everyone is good?
Yes.
Okay, so we can skip this as well. This gives you the critical value, which we have already got in this intermediate calculations, which is 2.145. Okay, so you can skip all these things and PHStat becomes much more easy. Confidence.t is used for the margin of error, which we do not need. We will just get it from here, interval half fit, which is 0.4707. Okay, so I just pointed out here, I would have deleted these slides, but then since the book uses that as well, so I wanted to add that also in the PowerPoint slide handout so that you know that what that means. Okay, so this is where what I did, it is right here. Okay. Now, when we do the confidence interval for proportions, okay, one more important thing. In chapter 7, we did that if the sample size is more than 30, we do not need to have any assumption. It can be approximated by a normal distribution. But if the sample size is less than 30, then we need the population should be normally distributed. And for the proportion, it can be approximated by normal distribution if we have at least 5 successes and at least 5 failures. So I'm just going over this quickly, and then I will take an example and I'll show you the summary of chapter 8 as well. So in this, you have sample proportion formula, which is x over n, where x is the number of observations of interest. Like if I'm given 40% out of 200 cross red light, so my 40% is my p bar, which is 0.4, and n is my 200. So if I want to find how many cross red lights, I will say 0.4 times 200. That's how I get x. And that's what I will be needing in my window. So the standard error we will need for intermediate calculation, you do not have to worry about of this formula. It is just for your understanding. You don't have to worry about any of these formulas, and then we will just do the calculation from PHStat. So let's take this example now for the proportion. It says 22 of 100 people are found to have blue eyes. Calculate a 98% confidence interval for the population proportion of blue eyes. So here my proportion is what? 22 out of 100, which is 22 divided by 100, it is 0.22. X is my 22. So I'll go to pH stat and confidence interval, and now I will be using estimate for the proportion. You see this? Okay. So we click on that. It needs sample size. And what's the sample size? 100. Number of successes is my X. So I'm already given number of successes, which is 22. Confidence level is 98. So you provide 98 here. Oops. And then you click OK. So it calculates for you sample proportion, which is 0.22. So you see here, that's what you needed if you are using the formula or Excel individual functions. You need the standard error, which it also gives you here 0.0414, which you see here 0.014.
Excuse me, can you
Interval
do,
half.
hello?
Yes.
Can you
Yeah.
redo it again? Because I missed that. I'm sorry.
Okay, so you do to pH stat, go to confidence intervals, and click on estimate for the proportion. Okay.
Got it.
Then provide the sample size, which is 100. Number of successes is X, which is 22. And then provide the confidence level, which is 98. And then click OK. Got it? So
Yes, I
we
got it.
need all, huh? Okay. So we need all these intermediate calculations, which we have, if we were using Excel functions, we will be doing by hand. It does give you here. So if I need sample proportion, I'll pick this number. If I need critical value, which is negative 2.33, you see here 2.33. Standard error, which is 0.0414. Interval half width is my margin of error, and my confidence interval is 0.1236.3164. Since it is proportion, I will say 12.36% to 31.64%. So I am 98% confident that the proportion of blue eyes for US citizens are between 12.3% to 31.6%. Do you understand? Everyone
Yes.
understood? Yes. Okay. So now next comes the sample size. So sample size for mean and standard deviation, sorry, mean and proportion. So we will use here pH stat, and you see sample size. If we need to find sample size for mean, we will choose determination for the mean. If we need for proportion, we will choose this one. So let me take the example from the book, homework problems from the book, because these examples on PowerPoint slides are already, I have calculated and I have added all the Windows outputs, what you need to put, and you can read that yourself. Let me take example from the book. Okay, does it sound good?
Yes.
Okay, so let's take an example, and let me open my chapter 8 summary as well, so that I will show you. Yeah. So this is the chapter 8 summary, which I have posted on Blackboard. So it does tell you what is point estimate, sample mean is the point estimate, sample proportion, which is X over N is the point estimate, what assumptions you need, sample size should be at least 30, or if not, then population should be normally distributed. And if it is mean, you're using estimate for mean sigma unknown, this one. And the output window gives you all these five things. If you need margin of error, that is your interval half width, confidence interval is this, degrees of freedom, standard error, validity, all these things are given in the chapter 8 handout. So this is one place which you can open when you are doing your homework problems, okay? So let's take this problem, 8.17. Okay, so it says construct a 90% confidence interval to estimate the population mean using the data. And now you see it is S. S is our sample standard deviation. So it is sigma unknown. So if we go to our Excel, we will go to pHstat, confidence intervals, and sigma unknown. And then confidence level is 90%. So I will provide 90. I'm given the sample statistics. My sample size is 22, so 22. Sample mean is 23. And sample standard deviation is 3.4. And I just click OK. I need confidence interval, so my lower limit is 21.75. Upper limit is 24.25. And that's what I will do.
I have a quick question
yes.
back to
Yes.
point estimate. So how would you find that, like with Excel? Like which one of those values like would represent
Point
the point
estimate is sample mean. This is the sample mean, which is point estimate 23.
Okay. So if that's the sample mean.
So sample mean is the point estimate. You are given here X bar. If it is not given, you are given the data and just find the mean of that data.
Okay, got it. Thank you.
Okay. So now see here, and the size of the sample is less than 30. It is 22. So what assumptions we need? We need that the population should follow normal probability distribution. Understood? Okay. Clear?
Yes.
Okay. So this is one of the example I did where we had the sample statistics known. Okay. Now let's take another example. Okay, let's take this example 27 where I'm given the data. Okay, so it says we're given the data for from Expedia.com. Workers in Italy lead the world in paid vacation days, averaging 42 days per year, and then you need to find 95% confidence interval to estimate the average number of paid vacations. Do the results from this sample as date. The findings of Expedia and verify the interval using Excel. You don't have to do with Excel and what assumptions you need to make. So let's open this one. And let me copy the data from here. Oops.
Really quick, if it doesn't give you a confidence interval, you just assume it's 95.
Yes, normally it will be given because you cannot find the interval without any confidence level. Because confidence interval does work with a given confidence level. So it has to be given.
With like population proportion, because on one of the, I'm pretty sure on one of our questions for the assignment I was looking over, it doesn't give a confidence interval for finding the point estimate for proportion.
So point estimate doesn't need confidence level. Point estimate is just the sample proportion. It's only for the confidence interval you need the confidence level.
Okay.
Okay. So this is the data I have copied. And okay. And let me pull up the problem we had. So, and we will do side by side. So it says that find the 5% confidence interval. So I go to this is mean, so sigma unknown. And now my confidence level is 95. Now I'm not given the sample statistic, that is, I'm not given sample mean and sample standard deviation. So I need to choose this input option. Sample statistic unknown. Now I will say it is sample cell range, so I will choose the range. Now here by default this is being checked, which is first cell contains label. So my first cell is C1. If I'm choosing from here, I included the label, so label should be checked. But if I'm choosing, say, so suppose if I'm choosing from here, I'm not including the label, I should uncheck. So be careful. It is by default, this is checked. So just do not hit enter just like that. You have to be careful what you have chosen from which cell. Okay? And then you click OK. So now I need the confidence interval. So my confidence interval is 32.71 to 47.59. Does it validate Expedia's claim? Expedia said averaging 42 days. Yes, it is within the confidence interval. So yes, it does validate. What assumptions do you need? What was the sample size? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 20. So sample size is 20, which is less than 30. So what assumptions you need to make? The assumptions is that the population is normally distributed. Now suppose if I need to find point estimate for this. Point estimate is what? The sample mean, which is my this one, 40.15. So this is my point estimate. Got it? Everyone understood?
Yes.
Okay. Now let me do one more problem for mean before I go to the proportion. So here, if you look for 21, 8.21, it says determine the margin of error for a confidence interval to estimate the population mean when n is 20 and s is 16 with the given confidence levels. Now margin of error depends upon the confidence level, but it doesn't depend upon the sample mean because it depends upon the standard deviation. So I'll go, instead of using the formula, I can go to the confidence interval with sigma unknown and I'll provide the confidence level. So I'm choosing for say 90%, and sample size is 20. Now I'm not given sample mean, I'm given sample standard deviation, which is 16. I cannot just hit enter because it needs sample mean. Now since margin of error doesn't depend upon sample mean, I can just provide any mean here. So just see sample standard deviation is 16, just provide a legitimate number. So let's say 25. It doesn't matter if I provide even 30, 35, but make sure don't provide such a huge number. It should be similar to sample standard deviation so that it doesn't mess up with extrapolation type of a thing. So if you click OK, we see margin of error, which is my interval half width, is 6.1863. Now notice here, if I change my sample mean to say 30, does my interval half width change? Does my interval half width change?
No.
No. So you will have one of the problems similar to this in your homework. And then you will say that, oh, I am not given the sample mean. So how I'm going to be calculating my margin of error from pH stat, right? So that's how you will be doing it. Everyone got that?
I saw somewhere in the handout that like we should put 0.5. If we don't know, is that like
Yeah, that is
like
for proportion. I'm coming for that. That is for the sample size.
okay.
Okay, so I have done right now for the population mean when data is given, when data is not given, finding the margin of error when you are given both sample mean, sample standard deviation, as well as when sample mean is not given, right? Now let's do for the proportion, and let's go to, say, page number. Okay, so let's say okay, let's do. Okay, this is the sample size. Let me just do one for the confidence interval.
Hi, Professor. I'm so sorry, but
Yes.
for the homework unit 4, I knew that you did it already, but just wanna asking. They say construct a 95% confident interval to estimate the population mean using the data below. So the X with the dash above is the average, right? And S is the success something, and N is the sample size, right?
X bar is the sample mean, S is the sample standard deviation. Now, when you are given the data, you do not need to calculate yourself those things. Let me show you here again, just the window itself.
Um,
So
but
in that, when you are given the data, then you are checking this one because you're not given sample mean or sample standard deviation.
oh, you are doing the estimate for the mean. I mean
Yeah,
the previous
that was for
problem.
estimate only.
I'm sorry.
I'm doing now whatever examples I covered that were for population mean. Okay,
Oh,
I haven't yet done any for the population proportion. So let me do that because I need to cover chapter 9 as well, few examples from the book. Okay,
okay.
so this is for the population proportion. So if I take number 29, okay, so it is asking you construct a 95% confidence interval for population proportion with sample proportion of 0.44 and sample size of 125. It says click on the portion of the table. You do not need that because we are using pH stat. So we will be using our pH stat. So let's go to our pH stat. Now, if I show you here in the confidence interval for proportion, we are choosing estimate for the proportion. We need sample size, we need number of successes, which is my X. Now, I'm given sample size, which is 125, but I'm not explicitly given number of successes. I'm given the sample proportion, which is 0.44. So I need to first find number of successes, and that will be 0.44 times 125. What that is meaning is 44% of 125 is my number of successes. Do you understand? Does everyone understand this part?
Yes.
You said population proportion, like number of successes would be 0.44?
Times 125.
Okay.
Because number of successes is a whole number. It is not fraction. It is this proportion is what? Percentage. I say you score 90%. So that is your proportion, right? I say 40% cross red line. That is a 40% of say 200 crossed red light, and if I want to find how many actual people crossed red light, I'm finding 40% of 200, that is 0.4 times 200, and that will be my number of successes. So the term itself tells you that it is not proportion, it is the number of successes which is being obtained from the proportion. So sometimes it is given to you, like the example I showed you earlier, it has 22 out of 100. So you are already given number of successes were 22. But here it says 44% of 125. You do not know how much that, so you need to first find that. So let's first find 44% of 125. So you do equal to 0.44 times 125. So it is 55. So my number of successes are 55. Now I'm ready to use my confidence
Sorry,
interval
where
estimate.
do you get the 200? I'm sorry.
No, I was just saying an example, arbitrary example. I didn't use 200 here.
So can you do the calculating again?
Okay, so here I have 44% of 125. So I did 0.44 times 125.
Got it. So that the success number? Success number?
Yes.
Yeah, okay, got it. Thank you.
So confidence interval, proportion, and then my sample size is 125 and successes are 55 and I need 95% and I click OK. So my confidence interval is 0.353 and upper limit is 0.527 and that's what my interval is. Understood?
Yes.
Yes. Okay. Now let's do another one where you are given, let's see this one. Number 34, it says the IRS reported that 81% of individual tax returns were filed electronically in 2012. A random sample of 225 tax returns from 2013 was selected. From this sample, 176 were filed electronically. Now notice here, this 176 is your number of successes. It is already given to you. You do not have to do any math. So when you need to find the interval for this, you go to estimate for proportion and you're providing sample size as 225 and number of successes as 176. And the confidence interval level is 95 and you provide this. So 95% confidence interval estimate is 72.83% to 83.6%. What is margin of error? Margin of error is 0.0539. Is there any evidence that this proportion has changed since 2012? In 2012, how much was it? 81%, right? It is between 72 to 83.6%. Has it changed? No, it hasn't changed because that is within this interval. Understood? Everyone understood?
Yes.
Okay. Now let's do one of the problems for the sample size. Okay. Okay, so let's do this one. So it says a certain region would like to estimate the proportion of voters. Now see here, it is for proportion, who intend to participate in upcoming elections. A pilot sample of 25 voters found that 19 of them intended to vote in the election. Determine the additional number of voters that need to be sampled to construct a 92% interval with a margin of error of 0.05. So we will go to our PH stat, sample size now for proportion. You need estimate of true proportion. Now here you are given that you took sample of 25 voters and out of that 19 intended to vote. So you do know the estimate of true proportion. That will be what? 19 divided by 25. So we need to first find here equal to 19 divided by 25. This is my estimate for true proportion. So I'll go here and I will provide 0.76 here, and sampling error is 0.07, which is my margin of error, and my confidence level is 92%, and then I click OK. So the sample size I needed is 115. So if it is asking you what is the sample size, then it is 115. But what it is asking you, additional voters. It is not asking the total sample size. How many you have already taken? 25. How many you needed? 115. So how many more you need? More than 25. So you are basically doing 115 minus 25. So you need how many additional voters? 90. Understood?
Yes.
Okay. Now let's take another example. Let's take this one. Now here it says a restaurant would like to estimate the proportion of tips that exceed 18% of its dinner without any knowledge of the population proportion. Now here we do not know the population proportion. So when we are finding this one, we are using sample size for the proportion. We do not know estimate of true proportion, and that's where we provide 0.5. Does it answer your question? Someone asked that in the handout it said 0.5. So that's where you provide 0.5 when you are not given the estimate of proportion. Okay. Sampling error is no more than 9%. So it is 0.09. And we need 99%. So here 99. And you click OK. So the sample size needed is 205. And it is asking you sample size needed. It is not asking you how many additional. So you are providing here 205. So read the problem carefully and then you answer. Does it make sense for everyone? Everyone is good? So this is our chapter 8 and
wait, I have a question.
Yes. So this is the chapter. Let me just complete this one. So this is the chapter 8 handout which I just showed you earlier. Everything what I have done is given in this handout also. Okay? Yes, what was your question?
Say for the sample size for a proportion and they wanted to find the sample size needed, and so they had like the confidence interval and the margin of error, but then they had like assumed standard deviation.
What? Say it again.
So, as like say in a question they had construct a 90% confidence interval, and they had a margin of error of 0.7, and then they said assume that the standard deviation is 2.0. So then for that one, finding the sample size, would you include the 2.0 in the estimate of the true proportion, or where would you put it?
If they're given the margin of error and they're given the point estimate, the sample mean, then the confidence interval is just that sample mean plus and minus of that margin of error. You are not doing any other thing.
No. Like the standard, the point estimate isn't given. It's just the confidence interval, the margin of error, and then the standard deviation.
So you are given confidence interval, you are given margin of error, and your given standard deviation. What you need to find?
The sample size needed.
Okay, so that is for me. So you're given population standard deviation, which is here. You will provide here. You will provide sampling error, which is a margin of error here, and you will provide confidence level here, and then click OK here.
Okay, thank you.
Okay. So this covers our chapter 8. Now let's go to our chapter 9. So in chapter 9, let me just point out a few things, and then I'll take an example because we are really running short of this. So in chapter 9, we are doing hypothesis testing. So again, we are not doing when the sigma is known, we are doing when sigma is unknown for the population mean, and then we are doing for the population proportion. So 9.2, we are not doing 9.3 and 9.4, that's what we are doing. So you need to pay attention on the symbols you are going to be using. You are testing the population parameter. So that's where your symbol should be either mu if it is mean or p if it is proportion. Now, hypothesis is basically an assumption or a statement which you would like to test statistically. So say if I want to test the mean data of smartphone users is 1.8 gigabytes per month. So my symbolic form of this statement is mu equal to 1.8. But if I say proportion of cell phone users with 4G contract is 62%, so my symbolic form will be P, because it is proportion, equal to 0.62, right? Now I have either this statement is true or this is not true. If this is not true, what will be true? The true will be that it is not equal to 1.8. It can be more or it can be less. Here also, the alternate of this will be what? It will be not equal to 62%. It can be more than 62% or less than 62%. That means when we are doing hypothesis testing, we have two hypotheses, two contradictory hypotheses. One is true, the other is not true. That's what it means. It's similar to like guilty or not guilty. So we in statistics define those two hypotheses as null hypothesis and alternate hypothesis. So what does null hypothesis mean? So null hypothesis is kind of status quo. So we start our testing by the assumption that null hypothesis is true, and then we grab the sample statistics and test statistically whether do we have enough evidence to support that null hypothesis is true or it is not true. So it is kind of status quo. So any statement which has less than equal to sign or equal to or greater than equal to sign is termed as null hypothesis. The contrary of that, say if it is less than equal to, contrary of less than equal to will be what? Greater than. Contrary of not of equal to will be not equal to. Contrary of greater than equal to will be less than. So any statement which is of this form is called alternate hypothesis. And any statement which has equality sign, whether in strict less than or strict greater than, that is null hypothesis. And this is very, very important for you to pay attention on. So our claim, so the components of hypothesis testing are these. So we have first the two contradictory hypotheses, null and alternate. Then you collect sample data. Then you use correct distribution, which we will do it from pH star. And pH star itself gives us everything. What you need to point out is that which one is your null hypothesis, which one is your alternate hypothesis. And the term which we use is test statistic. Statistic, why? Because it is coming from sample. And we are getting it from the sample, that characteristic, which becomes our testing kind of a thing that will give us the decision whether our sample supports our null hypothesis or do not support our null hypothesis. That's why it is called test statistic. Everything we will get in PhD. So we do not need any additional formula, any additional function in Excel, but you need to understand what these things means. So test statistic is the value which helps us to make a decision. Critical region is the one like we did the confidence interval, so confidence level. So if I say 10% is the level of significance or the probability of not being true, those are my borderline values corresponding to that. That is critical value, and the region on either side of that is called the critical region or the rejection region, because alpha is my probability of rejection and significance level is alpha. We have already seen critical value, what we mean by that. And p-value is the probability value which we get from the sample, and we have type 1 and type 2 errors. Okay, so these are the terms or the components which we use in hypothesis testing. So let's take an example and then I will guide you from there, and let me just show you one important slide here. So I took the example of that 1.8 gigabytes is the usage of data. So I'm having mu equal to 1.8. If it is not true, then what will be true? Mu not equal to 1.8. Which one is my alternate? The one which has not equal to sign. It means I have these two tails because it is what? It's a bell-shaped curve. So these two tails will have 10% of the probability, which is my alpha, the probability of rejection. So these shaded portions are my critical regions or the rejection regions. Now this unshaded portion is my do not reject region, because that's what the confidence level is telling me that it will be true. So that's what it means. But if I take, say, greater than type, that means this is my alternate. All 1.8 which is greater than is on my right side. So that is called upper tail test. If it is less than type, then my 1.8 is all on the left side. It is called lower tail test. So notice here that the tail test is being determined from your H1, the null hypothesis. Alternate hypothesis. Alternate hypothesis is being denoted by H1. So tail test is being determined from your alternate hypothesis, and we are doing the testing by the assumption that null hypothesis is true. Okay, so how we come to the decision of reject null or fail to reject or do not reject null, because we are starting with the assumption that null is true, so we can only make a decision on our null. So we will reject null or do not reject null, and I will show you when do you reject and when you do not reject. The tail test, the type of test which we will be using in PhStat, depends upon your alternate, which is H1, two tail if it is not equal to, upper tail if it is greater than, lower tail if it is less than. And the final part of the testing is the conclusion on the claim. Now your claim can be null, your claim may not be null. If it is null and you're rejecting null, that means you do not have enough sample evidence to your claim. But if you're rejecting null and your claim is alternate, that means your claim is true. So that's what the whole hypothesis testing is. So we have type 1 and type 2 errors as well. I'm just pointing it out too, and then I'll take the example, okay? So type 1 error is that we take the decision of rejecting null when it was actually true. So we are doing some error, and that error is called type 1 error, is also called your level of significance alpha. Type 2 is we fail to reject when it is not true. So let's understand the in the business world what it means. So in the manufacturing or quality control, suppose my null hypothesis is process is satisfactory and alternate is process is not satisfactory. So type 1 error will be what? You reject null when it is actually true. So you're saying that process is not satisfactory when it was actually satisfactory. So it is a producer's risk because you stopped the process when it was actually good. What will be type 2 error? Type 2 error is you do not reject null when it is false. That means you're accepting null, that you're saying process is satisfactory when actually it is not. So it is a consumer's risk. We are saying that the customer is getting a product which is not performing properly. So that's what type 1 and type 2 errors mean in our business world. Okay. So let's take the example and do from our PhStat. Here in the PowerPoint slides, you do have these solve examples which you can read, and these are all the steps which are given there. You can browse that. You do not need any of, calculations by hand or individual functions from Excel. So let's take example here. Okay, so the approach for taking the decision of rejecting or not rejecting are two approaches. One is p-value. If p-value is less than alpha, alpha is my probability of rejection. So if the probability from the sample you get even less than the probability of rejection, you reject null. Otherwise, you do not reject null. This is p-value approach, and when you use the test statistic, now this is the test statistic which we will find from PhStat, which is negative 2.07, and this T alpha is my critical value. This is my borderline value. Like if I had the confidence level given corresponding to that, this is my critical value. So if my test statistic falls in the critical region, so it is in the shaded region, you reject. If not, you do not reject. Okay, so as you saw in the earlier slide here, let me just show that one. Here. So if it was greater than, this was reject region. If it was left, it was this rejection region. And if it was two-tailed, then you do not reject if the test statistic is within the critical values, because within the critical values is this non-shaded portion. So that's what we use. Okay. So here you have the 9.3 summary, how to find, do the testing, full testing, and I'm going to use this one when I will do the example. So let's take an example from the book, and then we will do the whole process, okay? And I'll point it from the summary of 9.3, which is for mean, and then 9.4, which is for proportion. So let's take the example here. So it says, let me just click this one and then let's go to the okay. So it says during the winter of 2008 and 2009, the average utility bill for residents of a certain state was 184 per month. So during this year, it was 184. Random sample of 50 customers was selected during the winter of 2009 and 10, and the average bill was found to be 174.26 with a sample standard deviation of 19.81, and you need to complete these parts. So the first part is using alpha to be 0.05. So that means what confidence level we are choosing? 95%. So level of significance is 0.05. Does this sample provide enough evidence to conclude that the average utility bill in this state was lower in the winter of 2009 and 10 than it was in the winter of 2008 and 9? So let's see our summary here. First step is you need to see whether it is mean or proportion. Which example is this? This is about mean. So we are going to be using the right symbol, which is our mu. The next step is that you write the claim in words and symbolically. So what is my claim? Claim is that the average bill was lower, right? So what was in 2008 and 9? It was 184. So it is lower than 184. So my claim is what? Mu is less than 184.
It's not a big speaker. You have your own card, therefore you use your car speakers. You're gonna have to explain it.
Hello everyone.
You're actually cracking me up with like how we're sorry putting it. Wait, why wouldn't Callie be here? I'm confused by the but honestly, like date you and me.
You're not on mute. I'm sorry, but whoever's talking isn't on mute.
Okay, is everyone listening to me?
Yes.
Okay. So here my step is that it is mean, so I'm using mu as my symbol. And then I need to write my claim. My claim is that the average has gone lower than the winter of 2008 and 9. In 2008 and 9, it was 184. So my claim is mu is less than 184. Which statement has mu less than 184? Either in second or which one? The second one, right? Now, if it is less than 184, what will be its contrary? Greater than equal to, greater than equal to. Now, I need to see whether it is correct, null, and alternate. What is null means? Null should have equal to, less than equal, or greater than equal. See in the summary here. Yes, it does have null is greater than equal, and the alternate is one of the three, and it is less than. So this is my correct statement. Got it? So that is my up to step 2. Now I need to find critical value. So to find the critical value, as I mentioned, that one window itself gives you everything. So we are going to go to our one sample test, t-test for the mean, sigma unknown, and then I will provide the values in the dialog box, and then I will show up here. So let's open from our Excel. So we'll go to one sample test, and we are using t-test for the mean, sigma unknown. We are not using z-test for sigma known because sigma known is never there. So we are using t-test for sigma unknown, and it opens up this window. Now, null hypothesis means that what you are claiming, what number you are claiming, 184. So you are providing here 184. What is level of significance? 0.05, right? The level of significance was 0.05. So I'm providing 0.05. I'm given the sample size as 50. My sample mean is 174.26. And my sample standard deviation is 19.81. And then I need to check which test I'm doing. The test is from my alternate. My alternate is what? Less than type. So it is lower tail. Everyone got that?
Yes.
And then you click OK. So now I need critical value. What is my critical value? This lower critical value, negative 1.6766, 3 decimal places. So I'll do negative 1.677. Okay. Then it asks you what is test statistic. What is test statistics? Negative 3.476. So 2 decimal places, negative 3.48. Then it asks you what conclusion should be drawn. It does give you the decision here, reject null, right? So you are choosing either B or D. So it is either B or D. Now reject null, go back to your hypothesis. You are rejecting this, that it is not true. Then what is true? Alternate is true. That means yes, it has been lower than 2008 and 2009. So you need to choose the correct conclusion. So B says there is sufficient evidence to conclude that the average was lower in winter of 2009 than it was in this, which is correct statement, isn't it? Right?
Yes.
And then you click OK. Got it? Everyone got that?
Yes.
Yes.
So see, in one window itself, you get everything here. So let me show you again in our chapter 9 summary. So that's what it gives you, and that's what you put the numbers in. If the sample statistics are not given, then you choose the sample statistics unknown and you have the data in the column and you choose that column, and then you do exactly the same thing. The output window gives you all these things. So whatever you need to find, you are picking that number. And the conclusion, you are doing like this. So this is our chapter 9.3 section. So let's do one for the proportion. And let's say we go to okay, so let's do 9.26. Okay. Now it says an increased number of colleges have been using online resources to research applicants. According to study from last year, 38% of admissions. So it is proportion. So we will be using here one sample test, Z test for proportion. Okay. Now, if you look into this window, we need null hypothesis as we need it for our mean. We need level of significance and we need number of items of interest. It is exactly same as X, which we have done in chapter 8, the confidence interval. Either you are given or you are finding that. Understood? So here, first step is find the hypothesis. So it says, according to study from last year, 38% of admissions officers indicated that they visited an applying students' social networking page. A random sample of 400 admission officers was recently selected and it was found that 159 of them visit this thing. So I'm already given 159 as my number of number of items of interest. So I do not have to do any additional work here. Got it? So we do 159 here. My sample size is 400. My level of significance is 0.05. Now my null hypothesis is coming from the claim I'm going to be testing. So it says, does the sample provide support for the hypothesis that the proportion has increased in the past year? Past year proportion was 38%. Increase means it is greater than 0.38. Where is greater than? Either in A or C, right? Now I cannot choose C because with greater than, it is termed as null hypothesis. Null hypothesis does have equality sign. Alternate does not have equality sign, so this is not the correct. Greater than, strict greater than is my alternate hypothesis. So contrary to that is less than equal to, and it has equality sign, so it is my null hypothesis. So this will be my correct hypothesis. Understood?
Wait, why would that be correct? Because that's saying that P would be less than or equal to 0.38. I thought we were looking for it to be greater than or equal to.
Yeah, we are looking for greater than. Our claim is alternate in this case. So your claim can be null, your claim can be alternate. Your claim doesn't mean that it has to be null hypothesis. So you are first writing your claim, which is proportion is strict greater than 0.38, right? That is my claim. Now, since it is strict greater than, that is what type of hypothesis, null or alternate? Since it is strict greater than. Let's pull up this one. Oops. Oh. Okay, so if it is strict greater than, where does strict greater than comes? In H1 or H0? Hello?
H1.
H1, right? So that's what we are seeing here. Greater than is H1 in this one. In C, greater than is your H0, which is not the correct hypothesis. H0 is my null hypothesis. Null hypothesis can never be strict greater than or strict less than or not equal to. It is either equal to, see, it has to be either equal to, less than equal to, or greater than equal. Do you understand? Does it make sense? Okay. So I have put the note here. We always start hypothesis testing assuming null hypothesis to be true, like a status quo, and then gather information from the sample and look at the evidence in support of status quo and then make a decision on null hypothesis, irrespective of whether our claim is null or not. So in our case, our claim was alternate hypothesis. It was not null hypothesis. That's why our final step is the conclusion on the claim. Decision is on null, but conclusion is on the claim. Okay, so that's why you have to be very, very careful in identifying. First, you write the claim, which is whatever that claim is, and if it is strict, it will be your alternate. Everyone got this thing or no?
Yep.
Okay, so I selected the correct hypothesis. Now it says find the critical value. So to find the critical value, I'm using this and I will provide null hypothesis as 0.38 and the alternate tells me the type of tail test. It is strict greater than, so it is upper tail test. So you notice here the tail test is from the alternate. Decision is on null. Conclusion is on your claim. These are very, very important things. Null will have equality sign, whether it is strict equal or less than equal or greater than equal. Alternate is strict less than, strict greater than, or not equal. So these are the things which you need to pay attention to. So my critical value is 1.645. Now I need test statistics. So my test statistic is 0.721. So 0.72. And then I need the conclusion. Now, I do get the decision as do not reject null, but was my claim null hypothesis? My claim was not null hypothesis. My claim was alternate. So when I'm saying do not reject null, that means my claim, which is alternate, is false. So I'm choosing one of the A or D, do not reject. But then what conclusion I'm saying? There is sufficient evidence to support that the proportion has increased, or there is not sufficient evidence to support that the proportion has increased. So this is not true. Do you have enough evidence that it is increased? There is not sufficient evidence that it has been increased. So we are choosing D. Does it make sense?
Yes.
Understood? Everyone understood? Okay. So I would suggest you that please read these summaries to do the right conclusion of the claim. You do get the decision here, but then why you're getting that decision and what will be the conclusion on your claim. So this is your decision if we are using test statistic. If we are using p-value, this is the decision criteria. Okay? Everyone understood?
Yes.
So this completes our chapter 8 and 9, and let me show you here. These are the practice problems on chapter 9, detailed ones. So you should read that one as well. And it tells you what is your null hypothesis, what is your upper tail, which one is your claim, so that you do the right conclusion. Okay? And it does tell you why you came to that decision. So I have added 5 practice problems. So you read the handout to understand the concept, then go over the summary of each chapter, each section for chapter 9 while you do your homework problems or your assignments, and that will help you. Okay? Is
I have
everyone
a
doing good?
question about the Blackboard
Yes.
assignments. So it says to include our Excel file to show work. For which problems is that for?
So okay,
Is that
so
for all
say
13 of them?
yes. So see, this is the Excel window, right?
Okay, yeah.
So that's what I need. So if it is asking you critical value, how you have got? You have got from this window, isn't it?
Yeah.
So I want this to be included so that I know you have used the correct test, which is the test of hypothesis for proportion, and
Okay.
I see that you are plugging the right numbers here.
So you want us to just copy and paste just like that chart into each problem for 8 and 9?
Yes, yes,
Okay.
yes. So that I know, because I think I didn't specify that so harshly that you need to show your work, and I see the students submitting the assignments just with the answers. I don't know what they plugged in for chapter 6, for chapter 5, for chapter 7. So I'm not sure whether they just got the answer and then they just submitted the assignment, because I'm not able to see their work. So I'm not able to guide them where they are doing any mistake or like this. So I want to see that you have worked, and that's why I need this like the copy and paste, that what you have used in your PH stat to get to the answer. Okay?
Okay.
Does it make sense?
Yes.
Okay.